Today we are looking at lesson 11. You've learned about arithmetic sequences, geometric sequences, and now we just need to kind of practice knowing the difference, identifying them. So what we're going to do is we're going to turn to the next page, the opening exercises right here. And we're going to compare these sequences, figure out which type they are. We're going to figure out how it's changing, and then write recursive and explicit formulas. All right, so let's take a look at the first one. Here we go. This one goes from -2 to 2, 6, 10. If you notice, it's increasing by 4 each time. I'm adding, so that is definitely arithmetic. All right, then we have to go write formulas for each of them. I'm going to start with explicit. That's the general one. It's kind of nice because I always know I start with f of n. I start with the first term of -2. I find the difference of 4 n minus 1. Don't forget another way of writing that. You can distribute that 4 and get 4n, and then you'd get a -4 and -2 for a total of -6. All right, when we write recursive, recursive requires the term in front of it, right? It builds on it. Explicit, you can just put in any term you want to jump to, and it can do it, but not this one. All right, so recursive. So if I want f of n, that changes the variables I use. I could do f plus 1, meaning the next term. So I think I'm going to do that. It makes no difference which one you use. So I'm going to do f, I'm starting over here because there's no room, n plus 1. That means how do I get to the next term, right? So I'm going to start with the current term and add on 4. That builds to get the next one. All right, you could have written f of n equals f, then you'd have to start with the one before it plus 4. All right, just something to think about. It's just a preference. All right, let's go on to the next one. The next one's going to be, dun, 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 it's going up. It looks like it is doubling, so multiplying by 2. If it's multiplying by 2, that's geometric. It's multiplying. So I like to start with explicit. It's a little easier. All right, so f of n equals 2 to the n. That's our original function. You could also write f of n is 2 times 2 to the 1 before it. Alrighty. Remember how we broke that up? That was 2 to the n times 2 to the -1. Right? 2 to the n times 1 over 2. And then, whoa, we still have this 2. All right, if you notice, 1/2 of 2 is 1. 1 times 2n, oh, look, it takes us back to that problem right there. Phew, that was a lot of work. But just so you know, that's how I ended up with 2 to the n. I simplified that other longer equation. All right. Okay, let's go on. So, recursive. I'm going to keep filling in using f of n plus 1. That allows me to use f of n in my equation times 2. All right, let's go to the next one. 1/2, 1, 3/2, 2. It looks like it's getting bigger, like it's adding. Yep, it's adding by 1/2. So it's arithmetic. I'm going to do f of n equals I like to start with the first term, 1/2, plus 1/2 n minus 1. If you simplified that, you're going to get f of n equals 1/2 n. All right, over here, to get to the next term, I'm going to start with the current term I have and add on 1/2. Hopefully you're getting the gist. This one's multiplied by 1/3. Geometric. All right, I'm just going to jump to simplified. This is also geometric. You can multiply by 1/10 or 0.1, whichever you prefer. Started with my first term. I'm going to multiply by 1/10 and minus 1. I'm writing very tiny. Woo, I'm zooming in for you. There you go. All right, and this last one. It's getting smaller. Oh, it's getting smaller consistently by a -5. Arithmetic. Oh, I'm going straight to the simplified answer. All right. There you go. So, question number 2 says, how can you tell a sequence is geometric? What do you look for? I'm looking for any kind of multiplication, not addition, right? All right, so take a look at the top of the next page. Let's decide, do you think these are arithmetic, geometric, or none of the above? All right, give those 3 a turn. And you're all set. And if you're looking for more examples, look at this. Here's a little lesson summary to kind of wrap it up for you.